physicist, and that it says, even Puthoff likes this one better, and that is zero-point energy is the source, and of course somehow it gets back whatever you use, in waste heat or something. And so that's what Fiegel points out in the 2004 physical review letters. The fascinating thing about this, as I just explained about motion, is that we can also foresee, as Fiegel proposes, 100,000 volt per meter electric field, a 17,000 Tesla field magnetic field, and as you orient these perpendicularly, you literally force the dielectric medium, whichever dielectric medium you propose, like a liquid or something else, to move in one direction or the other. And of course, he's talking about a slow speed, but the fact that motion can be produced by the field from a very conservative theoretician is the sign we're moving in the right direction. Moving along to even a more tremendous breakthrough is Dr. Fronig. And what Fronig proposes, and this is also a quote from my feasibility study, is that the aerodynamic resistance of viscous drag exerted on the substructure of the vehicle, which in this case is a little saucer that he proposes, you'll see that in the next diagram, is compared to the Lorentz force that's exerted on the vehicle. And it literally allows the propagation speed and even the vehicle inertia to be accompanied by a distortion of the zero-point field. So why is this possible? Well, look at the similarities between sound and light. The speed of sound moving through a viscous medium has this kind of bunching up of the medium ahead of it. Even the various sound effects you get as a train goes by you or any other vehicle proves that. And the speed of light also shows a similar equation and a similar phenomenon. But no one has ever thought of the ether as being real. But now most physicists equate it to the zero-point field. And even the equation showing as the drag increases as you reach the speed of sound barrier, that matches the same thing that you find with the speed of light. So Fronig points out that not only do these small equations, evidential equations point in the right direction, but the two parameters, the permeability and permittivity, which are the magnetic and electric effects of the vacuum, they can be modified. And of course, there's also publication. This is in the American Institute of Aerodynamics and Astronautics. And his website, by the way, is quantumfields.com. Wonderful papers that you can download for free from there, showing the permeability and perturbation effects of a toroid. Notice how the toroid keeps popping up in a circular vehicle. He finds a circular vehicle is the most optimum shape for achieving this perturbation of the fields. And this is a cross-section of that circular field. So he's essentially proposing that as you get colder, which outer space, of course, is only a couple degrees absolute, the zero-point field loses its drag and transfers energy from the zero-point field to the vehicle. So I'm pleased to find that the developments in this area offer great hope for us, which also accompany some of the very erudite proposals by experts who have reviewed UFO reports, such as this one that was on the front page of the Washington Post in 1998. And this reached a journal as well. And what I cite here, and that's what I'm always focused on, the anecdotes are nice, but the technology is what I'm looking at. Gravity and inertial effects. That's exactly what we want. Do we see parallels in the other areas that we can find in the scientific literature? Well, as a matter of fact, Arthur C. Clarke gives us a little bit of hope. He points out, as I quote in the feasibility study, that in Hayes, Ruda, and Puthoff have proposed this effect of inertialess drive. The inertialess drive Clarke actually uses in his 3001 Odyssey book. And he essentially quotes, he says, if this theory is proven, the HR and P theory can be proven, it opens up the prospect, however remote, of anti-gravity space drives and the even more fantastic possibility of controlling inertia. And this, to me, is the real future that we have to be headed for. We can't visit the planets, much less the stars, if we don't have both gravity and inertia under our belts with onboard energy powering. And fascinating enough, Dr. Paul Hill from NASA, he's since passed away, but left this manuscript, which his daughter walked around for years with, and finally Dr. Bob Wood helped publish it, points out that all the different anecdotal reports of saucer-type vehicles actually obey physical laws, Newtonian laws, as a matter of fact. All you have to allow for is at least 10 Gs of force from the bottom. And then, of course, the inertial protection. So that's the most fascinating part about it. Most of them talk about inertia-free turns. And the inertia-free turns are something that you often don't believe. Everybody feels that way. A 10G reversal is probably an impossible one to imagine because the occupants normally would be killed if they don't have an inertial field protector around them. Well, as a matter of fact, I know from second-hand experience, I know the person who took this photo. And it was taken actually outside Stewart Air Force Base a few years ago in a place called Pine Bush. And what you're now finding is Discovery Institute and other people are now reporting on what they call flying triangles. And in fact, our next Future Energy e-News will report on the latest compilation evaluation of these flying triangles. Well, this was one of them. And what the photographer did is he, about 2 a.m., looking for these types of craft, he even saw one go slowly overhead so he could see the US insignia on the bottom. Back engineering happen. Back engineering is going on all the time. These aren't things from outer space most often. But they're classified, they're compartmentalized and so forth. But I don't want to get into too much of the politics here. The facts of the figures here you see is that you're looking overhead. And in this picture, you can actually see the fixed stars. So the camera didn't move during this picture, but it starts at the top. The vehicle actually moves across the sky and then abruptly makes a right-hand turn, which it recovers and then slowly starts continuing in the direction that it was going. So he did a lot of calculations to see how many Gs would be experienced. And the other fascinating part is, of course, those vehicles tend to add the red and green blinking lights as if they're conventional. So the FAA won't get too excited or something. And of course, we also emphasize there have been plenty of historical anti-gravity research. And I've been asked to at least address the issue of the difference between anti-gravity and electrogravitics, which this article talks about. This was an article that was written in a UFO magazine, which connects the work of Townsend Brown that I've published in an electrogravitics book, and also John Searle, who you just saw in that anti-gravity book. And see, Townsend Brown actually proposed, and I'm running out of my laser power here, the fact that the ionized flame jet generator can actually produce an electrogravitic field. Now that truly is not anti-gravity, even though some people might call it that. It's simply an electrically driven propulsion technique, which seems to exceed any ionic drive explanation that you can come up with. And on the left you see the drawing, actually by Dr. Paula Violette, who has a contributing paper in this book, showing how the B-2 bomber, which is as big as the B-52, charges the leading edges of the wings to a very high voltage and uses depleted uranium, very good dielectric, to insulate the rest of the craft. And then the flame jet generator produces the negative charges coming out the back. So, so this has been actually a very well-explained technology that Northrop has used, and they never really compensated Townsend Brown for it. But at least we've been publishing this book now for about a year, 10 years actually. We have the 10-year anniversary just recently. Giving some credit to the fact that these technologies are now being incorporated into aerospace companies. And I feel that you're going to see more of that, as certainly Dr. Greer believes too. So without pointing out too many of the details of how UFOs work, suffice it to say that propulsion theories are of great interest to people like us looking for signposts along the way. And one of the signposts that I had back in 1980 was when I read The Return of the Ancients by Norman Paulson. He was a follower of Yogananda, and basically I found an interest in what he had experienced, but the last half of the book was all about UFOs. And the 2 pages you see here on the right show not only the photograph of a daytime saucer appearance over a giant rock in California, but the policeman who took the photo, holding the picture in front of him. And to me, that has great credibility, besides the artist rendering below. So I went out, visited the community, spent a few days there, got to see the De Palma type sunburst machine they had created. And when they dealt with Paulson's description of magnets around the outer edge, they essentially thought it was a homopolar generator. That's what De Palma believed, that's why he built one. And so I followed suit. I said, let's research the homopolar generator. And so that's why I wrote this book on the homopolar handbook and did it for a master's project. However, since then, I've been coming across inventions that more specifically satisfy what Paulson originally described was his experience on a ship with a non-conducting disk the size of the ship and magnets supposedly around the outer edge. One of them is the Roshan and Godin experiment. And Roshan and Godin are cited on our website, but they also have journal articles and now a patent. I am happy to report the fact that they have now officially been awarded a US patent for their invention. And essentially, these are all homopolar generators going around the ring of, in this case, at least a meter size disk. And they have very anomalous effects. They're mounted on springs, calibrated springs. The whole platform wants to take off. They have lots of dampening effects to slow it down. You get graphs that basically start to level off and then they want to shoot upwards. The most fascinating, perhaps, for everyone that investigates this from a scientific point of view is the 7-degree temperature drop. 7-degree temperature drop in the vicinity of this craft, of this device. And what it turns out is that when you analyze all the volume of space that's being dropped in temperature, you find that equals approximately, to an order of magnitude, the electrical output, about 7 kilowatt output. And of course, we're dealing with anecdotal material on this. I found and connected an investor with them, and I'm happy to report there's great progress in reproducing all of the hardware that was used in that original experiment, which you just saw. So moving along into a similar type of device, the Brady motor is probably another one of great interest. And we just reported that on that in the last Future Energy e-News. And this is one developed by Mr. Brady in South Africa. He doesn't have a patent, so I guess he's trying to give it away. And he's identified all of the working mechanisms at his website, perendev-power.com. Where you can basically see a movie of this motor working as the stators come close to the rotors. Well, I'm involved in reproducing this experiment in its entirety, probably within the next month or so. And my initial measurements are at the top, where I already have found that because of the angle of the magnets, every single magnet is tipped about 15 degrees. And this is basically the secret, I believe, because what you end up with is a below zero reversal, field reversal on one side only of the magnetic field. And this is wonderful because asymmetry is what you need in all of these experiments, because otherwise magnetism will never be used for doing work. Also the good thing about this invention, which is different than all the magnetic motors you've seen for decades, is that neodymium iron boron magnets are very inexpensive today. So we now have great hope that this could be our next standalone energy source. And why does it work? Well, here's the explanation. If you look at the Hartmann patent, that's 4215330, you'll see a very unusual set of drawings, the one at the bottom and also the one at the top, where it shows permanent magnets assembled in a very asymmetric but also increasing magnetic field. And that's exactly what the Stern-Gerlach experiment on the left-hand side has done for years. It's called an inhomogeneous magnetic field, where it changes as you go across some distance. And when you have an inhomogeneous field, you can actually send a ball bearing, for example, up a 10-degree incline. You can actually accelerate it if it's on the horizontal. In other words, you're getting the magnetic field to do work. And why can you do that? By this classical equation, which you may barely be able to see at the bottom here, that is the dB dx. When you change the magnetic field with respect to x, you can get a force. And that's all these other inventions are doing. They're noticing that the magnetic field changes across a certain distance, and that's where the force is produced. So that essentially summarizes the scientific reasoning behind it. And of course, Hartmann has many examples as well. But you can take the Hartmann device, as Popular Science pointed out in 1979, and you can turn it into a circle. And once you do that, you have a spiral motor that, if these are repelling magnets, for example, the rotor and the stator, they tend to repel less strongly as the rotor goes clockwise. You can also do it in an attraction mode as well, and slightly different design. But it's called the magnetic Wankel. I invite you to try to get a back copy of June '79 Popular Science, and then you can read about the Japanese attempt. And this is exactly what I'm talking about. Here's an invention that had great promise, good funding, lots of patents. Almost a dozen Japanese patents were issued on this Kure-Teiko company technology, and yet they were dealing with ferrite magnets. So there wasn't much hope. Ferrite magnets are pretty weak. And of course, you see the very crude electromagnet trying to pulse it as it jumps the gap every time on every circle. Okay? So we've eventually see that there's lots of things happening, and why would a magnetic motor be valuable? Well, by using the flywheel concept. Flywheels are essentially very efficient at transducing and storing energy. And of course, if you have a magnetically powered flywheel, you got the best of both worlds. You can then use very weak torque, which would then be stored in a high velocity flywheel, and then use it for an automobile, which is exactly what Bitterly Flywheel will be developing shortly. They already have a business plan for doing that. And so we foresee the airport of the future essentially sooner than later, hopefully, as SearleEffect.com visualizes, both having circular craft and traditional aircraft. It's not funny. I believe this is our future. Thank you. And as you explore the facts of the matter, you'll see that more and more magazines also and journals agree. This last slide is from Aviation Week in Space Technology this year, March 1st, and it essentially identifies zero-point energy again, essentially proposing the same facts that I've shown you, Puthoff's articles, Fronig's developments, and the fact that we have to have this type of technology to reach the stars. Even astronauts now are getting on board, former astronauts, to propose the same thing. So thank you very much for your attention.
Can we take some questions at the panel session tonight?
Oh, sure. Okay. But we're out of time now? Oh, okay.
Thank you very much, Tom. Tom will be able to take some questions at the panel session this evening. Steve Greer is going to have to leave immediately after his presentation, so he will not be available for the panel session tonight. What we'd like to do now is adjourn for 15 minutes. Please be back promptly at 3:30. Again, Steve Greer has a limited amount of time, so if you want to hear his presentation in full, be back promptly at 3:30.
Could I take questions now, even though it's off the tape?
Sure. Yeah, anyone who wants to talk to you.
Yeah, if we got a 15-minute break, I mean, yeah, I don't know if they have questions, but.